What if every choice you've ever made, every path you took or didn't take, led to a completely different version of reality? A world where the rules of physics are rewritten, history unfolds differently, and even you might not be the same. This isn't science fiction. It's the multiverse, a concept so vast and mind-bending that it challenges everything we think we know about existence. Today, we're going to explore the mysteries of the multiverse and ask the ultimate question: could these infinite realms hold the key to understanding life, the universe, and the very fabric of reality? From the latest scientific theories to the profound philosophical questions they raise, we'll uncover what the multiverse might mean for us, and whether, somewhere out there, countless versions of ourselves are living out paths we never took. Let's dive in. To understand the multiverse, let's start with the basics. What exactly does it mean? At its core, the multiverse is the idea that our universe, complete with its galaxies, stars, and planets, is just one of an infinite number of universes. These other universes could be nearly identical to ours, with only minor differences, or they could be so alien that they operate under entirely different laws of physics. Picture a cosmic tapestry, where every thread represents a unique universe, each weaving its own story. Some threads might look familiar, while others are so strange they defy comprehension. Now, you might wonder, how could something so vast and unimaginable even be possible? Surprisingly, the concept of the multiverse isn't just a wild idea from science fiction. It's grounded in real scientific theories like quantum mechanics and string theory. Quantum mechanics, for example, suggests that at the most fundamental level, particles can exist in multiple states at once, a phenomenon known as superposition. Some scientists argue that this could mean every possible outcome of a quantum event spawns a new universe. Meanwhile, string theory, which attempts to unify all forces of nature, proposes the existence of extra dimensions beyond the three we experience. These dimensions could host other universes, hidden from our view but just as real. But here's where it gets even more fascinating. Not all multiverse theories are the same. Some suggest universes are stacked like pages in a book, separated by thin layers of space-time. Others imagine them as bubbles floating in an infinite cosmic foam, each bubble a self-contained universe. And then there's the idea of parallel universes, where every decision you make splits reality into two, one where you turned left and another where you turned right. The possibilities are as endless as the multiverse itself. So, what does this mean for us? If the multiverse exists, it could fundamentally change how we see reality. It raises questions about our place in the cosmos. Are we just one version of countless others? Could there be a universe where Earth never formed, or where life took a completely different path? These ideas might sound overwhelming, but they also open the door to profound new ways of thinking about existence itself. The multiverse isn't just a scientific curiosity, it's a window into the infinite possibilities of reality. And as we continue to explore it, we might just uncover secrets that reshape our understanding of everything we know. The idea of multiple universes might seem like a modern concept, but its roots stretch back thousands of years. Ancient thinkers like Democritus, often called the father of atomism, wondered if our world was just one of many. He imagined an infinite cosmos filled with countless worlds, each with its own unique nature. While Democritus didn't have the tools to prove his ideas, his vision planted the seeds for a question that would echo through the ages. Could there be more to reality than what we see? Fast forward to the 20th century, and the multiverse concept took a dramatic leap forward. In the 1950s, physicist Hugh Everett introduced the many worlds interpretation of quantum mechanics, a groundbreaking idea that shook the foundations of science. Everett proposed that every time a quantum event occurs, like the decay of an atom or the spin of an electron, the universe splits into multiple branches. In one branch, the atom decays, in another, it doesn't. Each outcome creates a new, parallel universe, meaning every possible quantum result happens somewhere. It's a mind-bending idea, but one that offers a solution to one of quantum mechanics' biggest puzzles: why particles seem to exist in multiple states at once. Around the same time, another revolutionary theory was taking shape: string theory. This ambitious framework attempts to unify all the forces of nature by imagining the universe's building blocks as tiny, vibrating strings. But here's the twist: string theory requires more than the three dimensions of space and one of time that we experience. It suggests the existence of up to 10 or even 11 dimensions, many of which are curled up so small we can't detect them. And within these hidden dimensions, countless universes could exist, each with its own unique set of physical laws. So, what evidence do we have for these theories? While we can't directly observe other universes, yet scientists have found intriguing clues. For example, the cosmic microwave background, the faint afterglow of the Big Bang, shows tiny irregularities that some researchers believe could be the imprint of collisions between our universe and others. And in the realm of quantum mechanics, experiments like the double-slit experiment continue to reveal the strange, probabilistic nature of particles, hinting at the possibility of parallel realities. The journey from ancient philosophy to cutting-edge science shows just how far we've come in our understanding of the multiverse. What began as a speculative idea has evolved into a framework that could explain some of the universe's deepest mysteries. Whether through the branching paths of quantum mechanics or the hidden dimensions of string theory, the multiverse remains one of the most compelling and challenging ideas in modern science. And as we explore its origins, we're reminded that the search for knowledge is never-ending, always pushing us to rethink what we thought we knew about reality itself. Quantum mechanics dives into the behavior of the tiniest building blocks of the universe, particles so small they defy our everyday intuition. At this scale, the rules of classical physics fall apart, replaced by a world of probabilities and uncertainties. Take an electron, for example. Unlike a ball rolling down a hill, an electron doesn't follow a single, predictable path. Instead, it exists in a haze of possibilities, only settling into a definite state when we observe it. This bizarre behavior is at the heart of quantum mechanics, and it's what makes the many worlds interpretation so intriguing. The many worlds interpretation, proposed by physicist Hugh Everett in the 1950s, offers a radical explanation for these quantum oddities. According to this theory, every time a quantum event occurs, like an electron choosing a position or a photon passing through a slit, the universe doesn't just pick one outcome. Instead, it splits into multiple branches, each representing a different possible result. In one branch, the electron moves left; in another, it moves right. Every quantum decision creates a new universe, meaning there could be an infinite number of realities, each slightly, or dramatically, different from our own. At first glance, this might sound like science fiction, but it's a serious scientific proposal designed to solve one of quantum mechanics' biggest puzzles: the measurement problem. In the quantum world, particles exist in a superposition of states, meaning they can be in multiple places or states at once until they're observed. But why does observation collapse this superposition into a single outcome? The many worlds interpretation sidesteps this question entirely. It suggests that the superposition never collapses. Instead, every possible outcome happens, but each unfolds in its own separate universe. This raises some profound questions about our place in the cosmos. If every quantum event spawns a new universe, then somewhere out there, every possible version of you exists. In one universe, you might have chosen a different career. In another, you might never have been born at all. These alternate realities aren't just hypothetical. They are mathematically consistent with the laws of quantum mechanics. But if they are real, could we ever detect them? That's where things get tricky. Detecting parallel universes isn't as simple as looking through a telescope. These alternate realities exist in their own separate branches of space-time, completely disconnected from ours. For now, the many worlds interpretation remains a theoretical framework, supported by equations rather than direct evidence. But it's a powerful idea that challenges us to rethink what we mean by reality. Is our universe just one thread in an infinite cosmic tapestry? And if so, what does that say about the nature of existence itself? What's fascinating is how this theory bridges the gap between science and philosophy. It forces us to confront questions about free will, identity, and the nature of choice. If every decision creates a new universe, are we truly making choices, or are all possibilities already playing out somewhere in the multiverse? These aren't just abstract thoughts, they're questions that could reshape how we see ourselves and our place in the universe. The many worlds interpretation may sound overwhelming, but it's also a testament to the power of human curiosity. It shows us that even the strangest ideas can emerge from rigorous scientific inquiry, pushing the boundaries of what we thought was possible. And as we continue to explore the quantum realm, we might just uncover clues that bring us closer to understanding the true nature of reality and our place within it. String theory is a bold and elegant attempt to answer some of the universe's most profound questions. At its heart, it proposes that everything, from the smallest particles to the vastness of space, is made up of one-dimensional, vibrating strings. These strings aren't just tiny, they're unimaginably small, trillions of times smaller than an atom. But here's the twist. The way these strings vibrate determines the properties of particles, like their mass and charge. In a sense, the universe is a cosmic symphony, with each string playing its own unique note. What makes string theory so revolutionary is its ambition. It doesn't just aim to describe particles, it seeks to unify all the forces of nature, gravity, electromagnetism, and the nuclear forces. For decades, scientists have struggled to reconcile gravity, which governs the cosmos on a large scale, with quantum mechanics, which rules the tiny world of particles. String theory offers a potential bridge between these two realms, suggesting that the same fundamental principles could explain everything from black holes to subatomic particles. But string theory doesn't stop there. To make the math work, it requires more dimensions than the three we're familiar with. Instead of just length, width, and height, string theory suggests the existence of up to 10 or even 11 dimensions. These extra dimensions are thought to be curled up so tightly that we can't perceive them, like the folds of an origami sculpture. And within these hidden dimensions, the theory predicts a vast landscape of possible universes, each with its own unique set of physical laws. This idea, known as the string theory landscape, is where the multiverse comes into play. Imagine a cosmic garden where each flower represents a different universe. Some flowers might look similar, with physical laws close to ours, while others could be wildly different, governed by forces and particles we can't even imagine. In some universes, gravity might be stronger. In others, stars might never form. The possibilities are as diverse as the vibrations of the strings themselves. So, how does this connect to the multiverse? If string theory is correct, our universe could be just one of countless others, each existing in its own pocket of space-time. These universes might be separated by distances so vast they're impossible to cross, or they could be stacked like layers in a cosmic cake, each layer hidden from the others. And because the laws of physics can vary from one universe to the next, the multiverse becomes a playground of infinite possibilities. Of course, string theory isn't without its challenges. For one, it's incredibly difficult to test. The strings and extra dimensions it predicts are far too small to observe with current technology, and the sheer complexity of the math involved has made it a topic of intense debate among physicists. But despite these hurdles, string theory remains one of the most promising frameworks for understanding the cosmos. What's truly remarkable is how string theory forces us to rethink the nature of reality. It suggests that the universe we see is just the tip of the iceberg, with an entire hidden world waiting to be discovered. Whether or not string theory is confirmed, it's already reshaped our understanding of space, time, and the very fabric of existence. And as we continue to explore its implications, we might just find that the multiverse isn't just a theoretical idea, it's the key to unlocking the deepest mysteries of the cosmos. What if the universe we know is just one bubble in a vast cosmic sea, a single ripple in an endless ocean of possibilities? Enter cosmic inflation, a theory that suggests the universe didn't just expand after the Big Bang, it exploded outward at an unimaginable speed, stretching space itself in a fraction of a second. This rapid expansion isn't just a fascinating idea, it's a cornerstone of modern cosmology, and it might hold the key to understanding the multiverse. Cosmic inflation proposes that in the first moments after the Big Bang, the universe underwent an exponential growth spurt. Picture blowing up a balloon, but instead of it growing steadily, it inflates billions of times faster than the speed of light. This isn't just a metaphor, it's what scientists believe happened to the fabric of space-time itself. And here's where it gets even more intriguing. This rapid expansion might not have been a one-time event. Some theories suggest that inflation could have happened in multiple regions of space, creating bubble universes that each expanded into their own separate realities. These bubble universes are thought to be like cosmic islands, forever isolated from one another by the vast stretches of space-time. Each bubble could have its own unique set of physical laws, constants, and even dimensions. In one bubble, gravity might be stronger, in another, the speed of light could be different. This means that while we're living in a universe where the laws of physics allow for stars, planets, and life, there could be countless other bubbles where the rules are so alien that life, as we know it, would be impossible. But how do we know any of this is more than just a wild idea? The evidence for cosmic inflation comes from some of the most precise measurements we've ever made of the universe. For example, the cosmic microwave background, the faint afterglow of the Big Bang, shows tiny fluctuations in temperature that match the predictions of inflation. These fluctuations are like cosmic fingerprints, suggesting that the universe underwent a period of rapid expansion. And if inflation happened once, why couldn't it happen multiple times, creating a multiverse of bubble universes? The implications of this theory are staggering. If cosmic inflation did create multiple universes, it would mean that our reality is just one of countless others, each with its own unique story. Some bubbles might have collapsed almost instantly, while others could have expanded into vast, complex universes like ours. And somewhere out there, in the infinite expanse of the multiverse, there could be universes where the constants of nature are so finely tuned that life flourishes in ways we can't even imagine. But here's the challenge: these bubble universes are, by their nature, forever beyond our reach. The space between them expands faster than light, making it impossible for us to ever observe or interact with them. This means that, for now, the idea of a multiverse remains a tantalizing possibility, one that's supported by math and theory, but not yet by direct evidence. Still, the concept of cosmic inflation and bubble universes pushes us to think bigger. It challenges us to consider that the universe we see is just a small part of a much grander cosmic picture. And as we continue to explore these ideas, we might just uncover clues that bring us closer to understanding not just our universe, but the infinite possibilities that lie beyond. Imagine a world where the dinosaurs never faced extinction, roaming the Earth alongside humans, or a reality where ancient civilizations mastered space travel thousands of years ago. These aren't just plot lines from science fiction, they're possibilities that the multiverse theory opens up. Parallel universes, a concept that has fascinated storytellers and scientists alike, suggest that there could be countless realities where history, physics, and even the course of life itself took entirely different paths. In a multiverse, every decision, every event could branch off into its own unique universe. Take something as simple as flipping a coin. In one universe, it lands on heads, in another, tails. But what if those choices were far more significant? What if, in one universe, the asteroid that wiped out the dinosaurs missed Earth entirely, leaving them to dominate the planet for millions more years? Or what if, in another, humanity never evolved, and Earth's ecosystems followed a completely different trajectory? The idea of parallel universes isn't just about alternate histories, it's about alternate realities. In some universes, the laws of physics might be so different that matter behaves in ways we can't even comprehend. Imagine a universe where gravity is 1,000 times stronger, crushing stars into black holes before they can even form. Or one where the fundamental forces are so weak that atoms can't hold together, making life as we know it impossible. But here's the question: if these parallel universes exist, how could we ever know? Detecting them isn't as simple as peering through a telescope. These realities are thought to exist in their own separate pockets of space-time, completely disconnected from ours. Some theories suggest that if two universes collided, we might see evidence in the form of strange anomalies in the cosmic microwave background, the faint glow left over from the Big Bang. Others propose that quantum entanglement, the phenomenon where particles can influence each other across vast distances, might offer a clue. The challenge of detecting parallel universes doesn't make them any less fascinating. In fact, it's what makes them so intriguing. They force us to think beyond the limits of our own reality and consider the infinite possibilities of existence. What if somewhere out there, there's a universe where every decision you made differently led to a life you can't even imagine, or a reality where the very fabric of existence is so alien that it defies description? The concept of parallel universes doesn't just expand our understanding of the cosmos, it challenges us to rethink what we mean by reality itself. Are we living in the only possible universe, or just one of an infinite number? And if the multiverse is real, what does that say about our place within it? These questions might not have answers yet, but they remind us that the universe, or universes, are far stranger and more wonderful than we often dare to imagine. Picture this: nearly 95% of the universe is made up of stuff we can't see, touch, or even fully understand. This invisible majority is dark matter and dark energy, two of the most mysterious and powerful forces in existence. While they dominate the cosmos, they've remained elusive, hiding in the shadows of our understanding. But here's where things get fascinating. Some scientists believe these enigmatic forces could hold the key to unlocking the secrets of the multiverse. Could dark energy be fueling the expansion of other universes? Or might dark matter be the hidden framework that ties the multiverse together? Let's step into the shadows and explore how the dark side of the universe might shape the infinite realms of existence. First, let's break down what we do know about dark matter and dark energy. Dark matter is an invisible substance that doesn't emit light or energy, yet its gravitational pull is so strong that it shapes the structure of galaxies and galaxy clusters. Imagine it as an unseen hand, sculpting the cosmos on a grand scale. Dark energy, on the other hand, is even more mysterious. It's the force driving the accelerated expansion of the universe, pushing galaxies apart at an ever-increasing rate. Together, these two forces make up the vast majority of the universe's content, yet they remain just out of reach of our current understanding. Now, here's where the multiverse comes into play. If dark energy is responsible for the expansion of our universe, could it also be driving the growth of other universes? Some theories suggest that in a multiverse, each universe might have its own unique amount of dark energy. In some, dark energy could be so weak that universes collapse back in on themselves almost immediately. In others, it might be so strong that galaxies are torn apart before they can even form. Our universe, with its just right amount of dark energy, might be a rare exception, a cosmic Goldilocks zone where life can thrive. But what about dark matter? Could it play a role in connecting these universes? One intriguing idea is that dark matter might act as a kind of cosmic glue, holding the multiverse together. If universes are like bubbles floating in a vast cosmic foam, dark matter could be the invisible threads that link them, creating a complex web of interconnected realities. This would mean that while we can't see or touch these other universes, they might still influence ours in ways we're only beginning to understand. The challenge, of course, is that both dark matter and dark energy are incredibly difficult to study. We can detect dark matter only through its gravitational effects, and dark energy reveals itself only through the accelerated expansion of the universe. But scientists are making progress. Experiments like the Large Hadron Collider and observatories like the James Webb Space Telescope are searching for clues, from exotic particles that might make up dark matter to subtle changes in the cosmic microwave background that could reveal the nature of dark energy. Each discovery brings us a step closer to understanding these shadowy forces and perhaps their connection to the multiverse. So, what does this all mean for us? If dark matter and dark energy are indeed the architects of the multiverse, they could reshape how we see reality. They might explain why our universe has the precise conditions needed for life, or why the laws of physics seem so finely tuned. They could also hint at a much larger cosmic picture, where our universe is just one piece of an infinite puzzle. The search for answers isn't just about uncovering the secrets of dark matter and dark energy. It's about exploring the very fabric of existence itself. As we continue to probe the mysteries of the cosmos, one thing is clear: the dark side of the universe holds more than just shadows. It might hold the keys to understanding the multiverse, and in doing so, illuminate the deepest questions about who we are and where we fit into the grand tapestry of reality. The journey is far from over, But every discovery brings us closer to shedding light on the dark and uncovering the infinite possibilities that lie beyond. What if the universe wasn't just random? What if it was designed for life? Imagine tweaking one of the fundamental constants of nature, like the strength of gravity or the charge of an electron, even slightly. If gravity were stronger, stars would burn out too quickly. If it were weaker, galaxies might never form. The universe seems to walk an incredibly fine line, with conditions so precise that even the smallest change could make life impossible. This delicate balance is known as the fine-tuning problem, and it's one of the most profound mysteries in science. The anthropic principle offers one possible explanation. It suggests that the universe appears fine-tuned for life because, well, we're here to observe it. In other words, if the constants of nature weren't exactly as they are, we wouldn't exist to ask these questions in the first place. It's a bit like finding a perfectly tailored suit and realizing it fits because you're the one wearing it. The universe isn't fine-tuned for life in general, it's fine-tuned for us. But here's where the multiverse comes into play. If there are countless universes, each with its own set of physical constants, most of them would be inhospitable to life. In some universes, gravity might be so strong that stars collapse into black holes instantly. In others, atoms might never form, leaving the cosmos a chaotic soup of particles. Our universe, with its just right conditions, would be one of the rare exceptions, a cosmic lottery winner where life can emerge and thrive. This idea raises an intriguing question: is fine-tuning evidence of a multiverse? Some scientists argue that in an infinite sea of universes, the odds of at least one having the right conditions for life approach certainty. It's not that the universe was designed for us, it's that we exist in the one universe where life is possible. This perspective shifts the focus from why is the universe like this to why are we here to observe it, yet not everyone is convinced. Critics of the multiverse explanation argue that it's a bit like saying, we won the lottery, so there must be infinite lotteries. While it's a compelling idea, it's hard to test or prove. Others suggest that there might be deeper, undiscovered laws of physics that explain why the constants of nature are what they are. Perhaps fine-tuning isn't a coincidence or a multiverse quirk. It's a clue pointing to a deeper truth about the universe. The debate over fine-tuning and the anthropic principle isn't just a scientific one, it's deeply philosophical. It forces us to confront questions about the nature of existence, the role of chance, and whether the universe has a purpose. Are we the result of random chance in a multiverse, or is there something more profound at work? These questions don't have easy answers, but they remind us that the universe is full of mysteries waiting to be explored. What's clear is that fine-tuning challenges us to think bigger. Whether it's evidence of a multiverse or a sign of deeper laws we've yet to uncover, it's a reminder of how extraordinary our existence is. Out of all the possible universes, we find ourselves in one that allows us to look up at the stars and wonder why. And that, in itself, is something worth exploring. What if everything you see, touch, and experience is nothing more than lines of code in an unimaginably advanced simulation? This is the bold premise of the simulation hypothesis, a theory that suggests our universe might not be the base reality at all. Instead, it could be an artificial construct, a digital universe running on a supercomputer built by a civilization far more advanced than our own. Think of it like a video game, but one so sophisticated that its inhabitants have no idea they're inside it. The idea isn't as far-fetched as it might sound. Philosophers like Nick Bostrom have argued that if a civilization becomes advanced enough, it could theoretically create simulations of entire universes. And if such simulations are possible, the number of simulated universes could vastly outnumber the real ones. In this scenario, the odds of us living in the one, true universe might be incredibly slim. It's a thought that bends the mind, but one that raises profound questions about the nature of reality itself. So, how would we even know if we're living in a simulation? Some scientists suggest that there could be subtle clues hidden in the fabric of our universe. For instance, if our reality is a digital construct, it might have a built-in resolution, much like a video game. At extremely small scales, we might find evidence of this tiny, pixel-like structures or anomalies in the behavior of particles. Others propose that glitches or inconsistencies in the laws of physics could hint at the underlying code of the simulation. But here's the twist. The simulation hypothesis doesn't just propose that our universe is a simulation. It suggests that the entire multiverse could be a digital construct. Imagine a vast network of simulated universes, each running on its own server, with their own unique rules and histories. In this scenario, the multiverse wouldn't be a collection of physical realms, but a series of interconnected simulations, each one as real to its inhabitants as our universe feels to us. Of course, this raises some big questions. If we're living in a simulation, who created it? Are the creators themselves simulations, nested within an even larger simulation? And if so, where does it all end? These questions might sound like the plot of a sci-fi movie, but they're part of a serious debate among philosophers, scientists, and technologists. The simulation hypothesis also challenges our understanding of free will and consciousness. If we're just lines of code, do our choices truly matter? Or are we following a predetermined script, unaware of the strings being pulled behind the scenes? These questions don't just test our knowledge of the universe. They force us to confront what it means to be alive, to think, and to exist. While the simulation hypothesis remains speculative, it's a fascinating lens through which to explore the multiverse. It blurs the line between science and philosophy, pushing us to question not just the nature of reality, but our place within it. Whether or not we're living in a simulation, the idea invites us to think bigger, to imagine possibilities beyond our current understanding. And in a universe or multiverse full of mysteries, that might be the most important question of all: how far does reality truly go? The silence of the cosmos has long been one of its most haunting mysteries. If the universe is so vast, with billions of galaxies and trillions of stars, why haven't we found any signs of intelligent life beyond our own? This is the heart of the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" It's a question that seems simple but cuts to the core of our understanding of existence. And when we bring the multiverse into the picture, the paradox becomes even more intriguing and even more perplexing. In a single universe, the Fermi paradox suggests that intelligent life should be abundant. With so many stars and planets, the odds of civilizations arising somewhere else seem almost certain. Yet, despite decades of searching, we've found no evidence of extraterrestrial intelligence, no signals, no artifacts, no signs of life at all. This cosmic silence has led to countless theories, from the idea that advanced civilizations self-destruct to the possibility that they're simply too far away for us to detect. But what if the answer lies beyond our universe? What if the multiverse holds the key to this mystery? In a multiverse, the Fermi paradox takes on a new dimension. If there are infinite universes, each with its own unique set of physical laws, life might be incredibly rare even across countless realities. Think about it. Most universes might have conditions so hostile that life never emerges. In some, gravity might be too strong, collapsing stars before planets can form. In others, the fundamental forces might be too weak, preventing atoms from bonding into complex molecules. Our universe, with its precise balance of constants, could be the exception rather than the rule, but there's another possibility. Intelligent life does exist in other universes, but we simply can't detect it. These civilizations might thrive in realities so different from ours that communication is impossible. Imagine a universe where the speed of light is much slower, or where time flows backward. How could we ever interact with beings from such a reality? In this scenario, the multiverse doesn't just explain the Fermi paradox, it transforms it into a question of accessibility, not existence. Some scientists speculate that advanced civilizations might even have the technology to move between universes, escaping the limitations of their own reality. If that's the case, the reason we haven't found them could be that they've already moved on, leaving behind a universe that's no longer hospitable. It's a chilling thought, but one that highlights the potential complexity of life in a multiverse. The multiverse theory doesn't just add layers to the Fermi paradox, it challenges us to rethink what we mean by life and intelligence. Are we alone because life is rare, or because the cosmos is far stranger and more fragmented than we ever imagined? The silence of the cosmos might not be a sign of emptiness, but a reminder of how much we still have to learn about the nature of existence itself. As we continue to search for answers, one thing is clear: the multiverse isn't just a scientific concept, it's a lens through which we can explore the deepest questions about our place in the universe. Whether it's explaining the Fermi paradox or revealing new possibilities for life, the multiverse invites us to look beyond the stars and into the infinite tapestry of reality. And in doing so, it reminds us that the search for meaning is as vast and mysterious as the cosmos itself. Time travel has long captured our imaginations, from H.G. Wells' The Time Machine to blockbuster movies like Back to the Future. But what if time travel isn't just a flight of fancy? What if, in a multiverse, it's not only possible but could fundamentally alter the fabric of reality itself? The idea of moving through time isn't just a sci-fi staple. It's a concept that some scientists take seriously, especially when viewed through the lens of the multiverse. Imagine stepping into a time machine and traveling back to a pivotal moment in history. According to some multiverse theories, your arrival wouldn't just change the course of events, it would create an entirely new branch of reality. In this scenario, the original timeline continues unaffected, while your actions spawn a parallel universe where history unfolds differently. It's like rewriting a chapter in a book, but instead of erasing the original, you add a new version alongside it. But how could this work? One possibility lies in the many worlds interpretation of quantum mechanics. If every decision creates a new universe, then altering the past could be seen as making a new choice, one that splits the timeline into two. For example, if you went back and prevented a historical event, the universe where that event still happened would continue to exist, while a new universe would emerge where it never occurred. This means that time travel wouldn't erase history, it would expand it, adding new layers to the multiverse. The implications of this are staggering. If time travel creates new branches of reality, it raises questions about causality, the idea that every effect has a cause. In a single universe, altering the past could create paradoxes, like the famous grandfather paradox, where traveling back in time to prevent your own birth would make your existence impossible. But in a multiverse, this paradox dissolves. Instead of erasing yourself, you'd simply create a new timeline where you were never born, while your original timeline remains intact. This also challenges our understanding of free will. If every decision creates a new universe, does that mean our choices are predetermined, or do we have the power to shape entirely new realities? Some philosophers argue that in a multiverse, free will becomes even more profound, as every possible action we take spawns a new universe. Others suggest that the multiverse might operate like a cosmic tree, with every branch representing a different path we could have taken. Of course, the idea of time travel within a multiverse isn't without its challenges. For one, the energy required to manipulate time on such a scale would be unimaginably vast. And even if we could achieve it, the consequences would be unpredictable. Could we ever return to our original timeline, or would we be forever adrift in an ever-expanding sea of realities? What's fascinating is how these theories blur the line between science and philosophy. They force us to confront questions about the nature of time, the limits of human agency, and the very structure of reality itself. Whether or not time travel is possible, the multiverse offers a new way to think about it, one where every moment holds infinite possibilities, and every choice we make ripples across the cosmos. As we explore these ideas, we're reminded that the universe, or universes, are far stranger and more complex than we often imagine. The concept of time travel within a multiverse doesn't just expand our understanding of reality, it invites us to dream of what might be possible. And in a cosmos of infinite possibilities, the only limit is our imagination. What if the three-dimensional world we experience is nothing more than an illusion, a projection of information stored on a two-dimensional surface? This is the essence of the holographic principle, a mind-bending idea that challenges our understanding of space, time, and reality itself. At its core, the principle suggests that all the information needed to describe our universe could be encoded on a boundary, like a cosmic blueprint etched onto the fabric of space. And when we bring the multiverse into the picture, this concept becomes even more profound. Could every universe in the multiverse be a hologram, a projection of higher dimensional information? Let's unravel this cosmic puzzle. The holographic principle first emerged in the study of black holes. Physicists discovered that all the information about matter falling into a black hole isn't lost. It's somehow preserved on the black hole's event horizon, the boundary beyond which nothing can escape. This idea led to a startling realization. If a black hole's information can be stored on a two-dimensional surface, maybe the entire universe works the same way. Think of it like a hologram, where a three-dimensional image is created from a flat, two-dimensional surface. In this case, the universe we see, the stars, planets, and galaxies might just be a projection of data stored on a hidden, lower-dimensional surface. But how does this connect to the multiverse? If our universe is a hologram, it's possible that other universes are too. Each one could be a separate projection, encoded on its own two-dimensional surface. These surfaces might exist in a higher dimensional space, like pages in a cosmic book, each one containing the information needed to create an entire universe. In this scenario, the multiverse wouldn't just be a collection of separate realms. It would be a vast network of holograms, each one a unique projection of higher dimensional data. This idea has profound implications for our understanding of reality. If the universe is a hologram, it means that what we perceive as solid, three-dimensional space might be an illusion. The objects around us, the stars above us, even our own bodies, could be projections of information stored somewhere else. It's a concept that stretches the limits of imagination, but one that's grounded in serious scientific inquiry. The holographic principle isn't just a fringe theory, it's a framework that some physicists believe could help unify quantum mechanics and general relativity, two of the most successful but seemingly incompatible theories in science. So, what does this mean for the multiverse? If each universe is a hologram, it suggests that the multiverse might be far more interconnected than we thought. The higher dimensional space that encodes these holograms could act as a kind of cosmic canvas, hosting countless universes, each one a unique projection. This would mean that while we perceive our universe as separate and distinct, it might be part of a much larger, interconnected structure, a cosmic web of holographic realities. The holographic principle also raises fascinating questions about the nature of information. If our universe is encoded on a two-dimensional surface, what kind of information is it? Is it like a computer program with code that dictates the laws of physics and the behavior of particles? And if so, who or what wrote that code? These questions might sound like they belong in a sci-fi novel, but they're part of a serious scientific exploration into the nature of reality. As we continue to explore the holographic principle, one thing is clear: it challenges us to rethink what we mean by existence. The universe we see might just be the tip of the iceberg, a projection of something far deeper and more complex. And if the multiverse is a collection of holograms, it suggests that reality is far stranger and more interconnected than we ever imagined. The holographic principle doesn't just offer a new way to understand the cosmos, it invites us to imagine a universe where the boundaries between dimensions blur, and the very fabric of reality is woven from information itself. What if the very act of observing the universe could change it? What if consciousness isn't just a passive bystander, but an active participant in shaping reality? This is the heart of one of the most intriguing ideas in modern science, the role of consciousness in the multiverse. Some theories propose that observers, yes, like you and me, might be essential to collapsing quantum probabilities into definite outcomes, effectively creating new branches of reality. It's a concept that bridges the gap between physics and philosophy, challenging us to rethink not just the multiverse, but the very nature of existence. Let's dive into this mind-bending connection between the observer and the observed. At the core of this idea is a phenomenon from quantum mechanics known as the observer effect. In the quantum world, particles don't exist in definite states until they're measured. Before observation, they're in a superposition, a mix of all possible states at once. It's only when we look that the particle chooses a specific state. This has led some scientists to suggest that consciousness itself might play a role in this process. Could it be that by observing the universe, we're not just witnessing it, we're shaping it? This idea takes on a whole new dimension when we bring the multiverse into the picture. If every quantum event spawns a new universe, as the many worlds interpretation suggests, then every observation we make could be creating a new branch of reality. Picture this: you're staring at a quantum particle in a lab, and as you measure it, the universe splits. In one branch, the particle spins up, in another, it spins down. Your act of observation isn't just collapsing probabilities, it's birthing new universes, each one a unique outcome of your measurement. But here's where it gets even more fascinating. If consciousness is tied to the creation of universes, what does that mean for the nature of reality? Are we, as observers, co-creators of the multiverse? This idea blurs the line between science and philosophy, raising questions about free will, identity, and the very fabric of existence. If every choice we make creates a new universe, does that mean we're living in a multiverse of infinite possibilities, each one shaped by the decisions of countless conscious beings? Of course, this theory isn't without its critics. Some argue that consciousness is too vague a concept to be tied to something as precise as quantum mechanics. Others suggest that the observer effect could be explained without invoking consciousness at all. For example, the interaction between a measuring device and a quantum system might be enough to collapse probabilities without any need for a conscious observer. Yet, the idea of consciousness shaping the multiverse continues to captivate scientists and thinkers alike. It challenges us to consider that the universe might not be a fixed, external reality, but something more dynamic, a reality that's deeply intertwined with the act of observation. In this view, the multiverse isn't just a collection of separate universes. It's a living, evolving tapestry, woven together by the choices and observations of conscious beings. This connection between consciousness and the multiverse also opens up profound philosophical questions. If we're shaping reality through our observations, what does that say about the nature of existence? Are we merely passive participants in a predetermined universe, or active creators of our own realities? And if the multiverse is shaped by consciousness, could there be other forms of consciousness out there, shaping their own universes in ways we can't even imagine? As we explore these ideas, we're reminded that the multiverse isn't just a scientific concept. It's a gateway to deeper questions about who we are and our place in the cosmos. Whether or not consciousness plays a role in shaping the multiverse, the very possibility invites us to think bigger, to imagine a reality where the boundaries between the observer and the observed blur, and where the act of looking might just be the most powerful force of all. What if the universe isn't just described by mathematics? What if it is mathematics? This is the bold claim of the mathematical universe hypothesis, a theory that suggests every possible mathematical structure isn't just an abstract concept, but a real, physical universe. In this view, the cosmos isn't made of atoms or energy. It's made of numbers, equations, and geometric shapes. And when we apply this idea to the multiverse, it opens up a breathtaking possibility. Every mathematically consistent universe could exist somewhere in the grand tapestry of reality. But what does that actually mean for us, and how does it connect to the world we experience every day? At its core, the mathematical universe hypothesis flips the script on how we think about physics. Instead of using math as a tool to describe the universe, it suggests that math is the universe. Every equation, every geometric shape, every possible configuration of numbers corresponds to a real, physical reality. Picture a vast library where each book represents a different mathematical structure. Some books might describe universes similar to ours, with stars, planets, and galaxies. Others could depict realities so alien that they defy imagination, universes with extra dimensions, alternate laws of physics, or even entirely new forms of existence. This idea might sound abstract, but it's rooted in a deep insight. Mathematics has an uncanny ability to describe the physical world with incredible precision. From the motion of planets to the behavior of subatomic particles, math seems to be the language of the universe. The mathematical universe hypothesis takes this a step further, proposing that this isn't a coincidence, it's because the universe is, at its most fundamental level, a mathematical structure. But here's where things get really interesting. If every mathematical structure corresponds to a physical universe, then the multiverse becomes a vast collection of these structures. Some universes might be governed by the same equations as ours, while others could operate under entirely different rules. For example, one universe might have 5 spatial dimensions instead of 3, while another might have a completely different set of fundamental particles. The diversity of the multiverse, in this view, is as limitless as the diversity of mathematics itself. Now, you might be wondering, if the universe is fundamentally mathematical, how do we reconcile that with our physical experience? After all, we don't experience the world as numbers or equations. We see colors, feel textures, and hear sounds. The key lies in the way these mathematical structures manifest as physical reality. Think of it like a video game. The game's world is built on code, a mathematical framework, but what we see and interact with are the graphics, sounds, and gameplay. Similarly, the mathematical structures of the universe give rise to the physical phenomena we experience, from the warmth of sunlight to the pull of gravity. This hypothesis also raises profound questions about the nature of existence. If every mathematical structure is a universe, does that mean there's a universe for every possible equation? Could there be a universe where 2 plus 2 equals 5, or where circles have corners? The answer, surprisingly, is no, at least not in the way we might think. The mathematical universe hypothesis focuses on consistent structures, those that follow logical, self-consistent rules. A universe where 2 plus 2 equals 5 wouldn't be consistent, so it wouldn't exist in the multiverse. But within the bounds of consistency, the possibilities are endless. The mathematical universe hypothesis doesn't just challenge our understanding of the cosmos, it invites us to see reality in a whole new way. It suggests that the universe isn't just governed by math, it is math. And as we explore this idea, we're reminded that the search for knowledge isn't just about uncovering the secrets of the universe. It's about discovering the language in which those secrets are written. Whether or not the mathematical universe hypothesis is proven, it offers a fascinating lens through which to view the multiverse, one where the boundaries between numbers and reality blur, and the infinite possibilities of existence unfold in the language of mathematics. The human brain is a marvel of evolution, finely tuned to navigate the world around us. It's built to solve problems, recognize patterns, and make sense of the finite, the kind of reality we encounter every day. But when it comes to the multiverse, our mental toolkit hits a wall. How do we wrap our minds around something as vast and abstract as infinite universes? The challenge isn't just intellectual, it's deeply rooted in the way we've evolved to think. Imagine trying to explain the concept of infinity to someone who's never seen the ocean. You might describe it as endless water stretching to the horizon, but your description would still be limited by their frame of reference. In the same way, our brains struggle to grasp the sheer scale of the multiverse. We're wired to think in terms of beginnings and endings, cause and effect, and the tangible world we can see and touch. Infinity, by its very nature, defies these instincts. It's not just big, it's beyond big. It's a concept that refuses to fit neatly into the mental boxes we've built. Yet, history shows us that human understanding isn't static. Over centuries, we've pushed the boundaries of what we thought was possible. Think about how our ancestors viewed the cosmos. For much of human history, the Earth was thought to be the center of the universe, with the stars and planets orbiting around us. It took a radical shift in perspective, a leap of imagination, to realize that we're just one small part of a much larger system. The multiverse might demand a similar leap, one that takes us beyond the limits of our everyday experience. So, how do we begin to tackle something as vast as the multiverse? One approach is to break it down into smaller, more manageable pieces. Instead of trying to picture infinite universes all at once, we can focus on specific theories or analogies that help us make sense of the bigger picture. For example, the idea of a cosmic foam, where each bubble represents a separate universe, gives us a visual framework to work with. It's not a perfect representation, but it's a starting point, a way to anchor an abstract idea in something more concrete. Another tool at our disposal is mathematics. While our brains might struggle with the concept of infinity, math offers a language to describe it. Equations and models allow us to explore the multiverse in ways that go beyond intuition, revealing patterns and possibilities that might otherwise remain hidden. Even if we can't fully visualize infinite universes, math gives us a way to reason about them, to ask questions and test ideas. But here's the thing. Grappling with the multiverse isn't just about expanding our intellectual horizons, it's about embracing the unknown. It's about recognizing that some questions might not have answers, at least not yet, and that's okay. The multiverse invites us to sit with uncertainty, to marvel at the mysteries of existence without feeling the need to solve them all. In a way, the limits of human understanding aren't just a barrier, they are an invitation. They remind us that the universe, or universes, are far stranger and more wonderful than we often imagine. And as we continue to explore these ideas, we're not just learning about the cosmos, we're learning about ourselves, about the incredible capacity of the human mind to reach beyond its limits and imagine the unimaginable. The multiverse might challenge us, but it also inspires us to keep asking, keep exploring, and keep dreaming of what might lie beyond the horizon of our understanding. How do you search for something that might lie forever beyond your reach? That's the question scientists face when it comes to finding evidence of the multiverse. If other universes exist, they're likely separated from ours by unimaginable distances or hidden behind barriers we can't cross. But just because we can't see them directly doesn't mean we can't look for clues, imprints left behind in the fabric of our own reality. This is where the cosmic detective work begins, and it's leading us down some fascinating paths. One of the most promising places to search for evidence is the cosmic microwave background, or CMB. This faint glow, the afterglow of the Big Bang, is like a snapshot of the universe in its infancy. Scientists have discovered tiny temperature variations in the CMB, and some believe these irregularities could be the fingerprints of other universes. For instance, if our universe collided with another in the distant past, the impact might have left a mark, a kind of cosmic bruise in the CMB. Researchers are scouring the data for these subtle patterns, hoping to find signs that our universe isn't alone. But the search doesn't stop there. Particle physics offers another avenue for exploration. Experiments at facilities like the Large Hadron Collider are probing the fundamental building blocks of the universe, searching for particles or forces that don't fit our current understanding. If another universe exists, its gravity or other forces might leak into ours, creating anomalies that we could detect. Think of it like hearing faint whispers from a neighboring room. You might not see the source, but you know something's there. Of course, the challenges are immense. Indirect evidence is notoriously difficult to interpret, and the signals we're looking for could be incredibly subtle. The cosmic microwave background, for example, is already incredibly uniform, with temperature variations measured in millionths of a degree. Finding a definitive imprint of another universe would require precision on an unprecedented scale. And in particle physics, distinguishing between a multiverse signal and ordinary background noise is like trying to spot a single grain of sand on a beach. Despite these hurdles, there have been tantalizing hints. Some researchers have pointed to unusual, cold spots in the CMB regions that are slightly cooler than their surroundings. Could these be evidence of a collision with another universe? It's a possibility, but not everyone is convinced. Skeptics argue that these anomalies could have more mundane explanations, like instrumental errors or statistical flukes. The hunt for evidence is as much about ruling out false leads as it is about finding the real thing. What's remarkable about this search is how it pushes the boundaries of science. It forces us to ask questions we might not have considered otherwise, like how we define evidence or what it means to prove something exists. Even if we never find definitive proof of the multiverse, the process of looking changes how we see the cosmos. It reminds us that the universe is full of mysteries waiting to be uncovered, and that the search for knowledge is as much about the journey as it is about the destination. As we continue to explore, one thing is clear: the multiverse isn't just a scientific idea, it's a challenge to our imagination. It invites us to think beyond the limits of what we can see and to consider that reality might be far more complex than we ever imagined. Whether or not we find evidence, the search itself is a testament to the human spirit of curiosity and discovery, a reminder that the cosmos is full of wonders waiting to be explored. The multiverse isn't just a scientific concept, it's a philosophical labyrinth, one that challenges us to rethink the very foundations of existence. If there are infinite universes, each with its own version of reality, what does that mean for us? Does our life hold any unique significance, or are we just one thread in an infinite cosmic tapestry? These questions might sound abstract, but they cut to the core of what it means to be human. Let's explore the profound philosophical implications of the multiverse and how it reshapes our understanding of identity, purpose, and meaning. First, consider the idea of identity. In a multiverse, there could be countless versions of you, some almost identical, others wildly different. In one universe, you might be a doctor, in another, an artist. In some, you might never have been born at all. If every decision creates a new branch of reality, does that mean you are spread across infinite possibilities? Or is there something uniquely you that transcends these alternate versions? It's a question that challenges our sense of self, forcing us to ask, what makes us who we are? This leads us to the concept of meaning. If there are infinite realities, does anything truly matter? In a single universe, our choices feel weighty because they shape the course of our lives. But in a multiverse, every possible outcome happens somewhere. Does that make our decisions less significant, or does it amplify their importance? Some philosophers argue that the multiverse doesn't diminish meaning, it expands it. Every choice we make becomes part of a vast, interconnected web of possibilities, each one contributing to the infinite diversity of existence. Then there's the question of purpose. If our universe is just one of many, does it have any special role, or is it one among countless equals? Some might see this as a humbling perspective, reminding us that we're part of something far greater than ourselves. Others might find it unsettling, as though our existence is just a cosmic accident. But perhaps there's another way to look at it. If we're living in a universe where life can emerge and thrive, isn't that itself remarkable? The multiverse doesn't just challenge us to find meaning, it invites us to create it. These questions aren't just theoretical, they are deeply personal. They force us to confront what we value, what we believe, and how we see ourselves in the grand scheme of things. The multiverse doesn't provide easy answers, but it does offer a new lens through which to explore these timeless questions. Whether it's through the lens of science, philosophy, or personal reflection, the multiverse invites us to think bigger, to imagine a reality where every possibility exists, and every choice matters in ways we're only beginning to understand. As we grapple with these ideas, one thing becomes clear: the multiverse isn't just about the cosmos, it's about us. It's about how we see ourselves, how we find meaning, and how we navigate the infinite possibilities of existence. And in this vast, interconnected tapestry of realities, perhaps the most profound question of all is this: what does it mean to exist, not just in one universe, but in all of them? What if every choice you make doesn't just affect your life? It creates an entirely new universe. This idea, central to many multiverse theories, isn't just a mind-bending thought experiment. It raises profound ethical questions. If every decision spawns a new reality, are we accountable for the consequences in those other worlds? Should guilt or responsibility extend beyond the universe we inhabit? These aren't just philosophical musings, they're dilemmas that could reshape how we think about morality itself. Let's start with a simple example. Imagine you're faced with a difficult decision, like whether to take a job in a new city or stay where you are. In a multiverse, both choices happen. In one universe, you move, build a new life, and thrive. In another, you stay, and things don't go as planned. But here's the twist: both realities exist simultaneously. Does that mean you're responsible for the outcomes in both? If the version of you who stayed is miserable, do you share the burden of that pain, even if it's not your reality? This idea becomes even more complex when we consider decisions with far greater stakes. Take climate change, for instance. If our actions lead to environmental collapse in one universe but not another, does that absolve us of responsibility? Or does it mean we're obligated to act in ways that minimize harm across all possible realities? In a multiverse, the ripple effects of our choices could stretch infinitely, making the ethical implications of even small decisions staggeringly vast. Some philosophers argue that in a multiverse, traditional notions of morality might need to be rethought. If every possible outcome happens somewhere, does it even matter what we do? After all, no matter how carefully we weigh our choices, there will always be a universe where things go wrong, but others suggest that the multiverse amplifies the importance of morality. If our actions create new realities, then every decision becomes a responsibility, a chance to shape not just one world, but many. Then there's the question of intent. In our universe, we often judge actions based on their outcomes. But in a multiverse, where every possible outcome occurs, should we focus more on the intentions behind our choices? If you act with kindness and compassion, even if things go awry in some realities, does that make your choice ethically sound? This shifts the emphasis from results to the values that guide our decisions, offering a new way to think about right and wrong. Of course, these ethical dilemmas aren't just abstract. They have real-world implications. If the multiverse is real, it could influence how we approach everything from personal relationships to global policies. It challenges us to consider not just the immediate consequences of our actions, but their potential impact across countless realities. It's a perspective that demands humility, empathy, and a willingness to think beyond the boundaries of our own experience. As we wrestle with these questions, one thing becomes clear: the multiverse doesn't just expand our understanding of the cosmos, it expands our understanding of ourselves. It forces us to confront the weight of our choices, the complexity of morality, and the interconnectedness of all possibilities. Whether or not the multiverse exists, the ethical dilemmas it raises remind us that every decision matters, not just for us, but for the infinite tapestry of realities that might lie beyond. In the end, the multiverse isn't just a scientific idea, it's a mirror reflecting the profound questions at the heart of what it means to be human. And as we explore these ethical dimensions, we're reminded that the search for knowledge isn't just about uncovering the secrets of the universe, it's about understanding our place within it and the responsibilities we carry in shaping the infinite possibilities of existence. Imagine a machine so powerful it could simulate entire universes, or a device sensitive enough to detect ripples from another reality. This isn't science fiction, it's the future of technology, and it could hold the key to unlocking the mysteries of the multiverse. As we peer into the cosmos, we're not just relying on telescopes and theories, we're building tools that might one day allow us to explore realities beyond our own. From quantum computers to massive particle accelerators, the cutting edge of technology is pushing the boundaries of what we thought was possible. But how far can we go, and what role will these advancements play in our quest to understand the multiverse? Let's take a closer look. Quantum computers are at the forefront of this technological revolution. Unlike classical computers, which process information in binary bits, zeros and ones, quantum computers use qubits, which can exist in multiple states at once. This allows them to perform calculations at speeds that would take traditional computers millions of years. For scientists studying the multiverse, this is a game changer. Quantum computers could simulate complex quantum systems, giving us insights into how other universes might behave. They might even help us model the conditions of the Big Bang, offering clues about how other universes could have formed. But quantum computing is just the beginning. Particle accelerators, like the Large Hadron Collider, are already probing the fundamental building blocks of reality. By smashing particles together at incredible speeds, these machines recreate conditions that haven't existed since the early moments of the universe. Some scientists speculate that these collisions could produce signatures of other universes, tiny anomalies in energy or particle behavior that hint at something beyond our own reality. While we haven't found definitive proof yet, the possibility is tantalizing. Then there's the question of detection. If other universes exist, how could we ever observe them? One promising avenue is gravitational waves, ripples in space-time caused by massive cosmic events like black hole collisions. Advanced detectors, like LIGO and Virgo, are already listening for these waves. Some theories suggest that if our universe collided with another, it might leave a faint imprint in the gravitational wave background, a kind of cosmic fingerprint waiting to be discovered. But technology isn't just about detection, it's also about exploration. Imagine a future where we could send probes or sensors into other dimensions, gathering data from universes with different physical laws. While this might sound like the stuff of dreams, some physicists believe that breakthroughs in quantum entanglement, where particles remain connected across vast distances, could one day allow us to transmit information between universes. It's a long shot, but it's a reminder that the limits of technology are constantly being redefined. Of course, these advancements come with challenges. Building machines powerful enough to simulate or detect other universes requires not just innovation, but collaboration. Scientists, engineers, and technologists from around the world are working together to push the boundaries of what's possible. And as we develop these tools, we're also grappling with ethical questions. What happens if we discover a universe that's hostile or fundamentally different from our own? How do we balance the pursuit of knowledge with the potential risks? What's clear is that technology isn't just a tool, it's a bridge to the unknown. It's how we extend our reach beyond the limits of our senses, exploring realities that might otherwise remain hidden. And as we continue to innovate, we're not just building machines, we're building possibilities. Whether it's through quantum simulations, particle collisions, or gravitational wave detectors, technology is our guide in the search for the multiverse. As we look to the future, one thing is certain: the quest to understand the multiverse will be driven by the tools we create. These advancements won't just expand our knowledge, they'll redefine what we thought was possible, opening doors to realities we can't yet imagine. And in this journey, technology isn't just a means to an end, it's a testament to the power of human curiosity and ingenuity, reminding us that the search for answers is as limitless as the multiverse itself. The multiverse isn't just a scientific concept, it's a wellspring of creative inspiration, sparking the imaginations of storytellers, artists, and dreamers across the globe. From the pages of comic books to the silver screen, the idea of infinite realities has woven itself into the fabric of our culture. It's a theme that resonates deeply, offering endless possibilities for exploration and reflection. But why does the multiverse captivate us so profoundly? And what does its prevalence in art and media reveal about our shared fascination with the unknown? Take comic books, for example. Marvel and DC have long embraced the multiverse as a narrative playground, crafting stories where heroes and villains exist in countless variations. Spider-Man isn't just one person, he's a web of interconnected identities, each shaped by their own unique circumstances. These stories don't just entertain, they invite us to ponder what it means to be a hero, to make choices, and to confront the infinite versions of ourselves that might exist in other realities. Filmmakers have also embraced the multiverse as a storytelling device. Blockbusters like Everything Everywhere All at Once and Doctor Strange in the Multiverse of Madness explore the emotional and existential weight of infinite possibilities. These films aren't just about flashy special effects or alternate realities, they are about the human experience. They ask us, if you could see every version of your life, would it bring clarity or chaos? Would it make you feel more connected to your choices or less? But the multiverse isn't confined to action-packed stories. It's also a powerful metaphor in literature and art, offering a lens through which to explore identity, regret, and the paths not taken. Novels like The Man in the High Castle by Philip K. Dick imagine alternate histories, while visual artists use the concept to create kaleidoscopic works that blur the line between reality and imagination. The multiverse becomes a canvas, inviting us to explore the infinite possibilities of existence in ways that are both personal and universal. Perhaps what makes the multiverse so compelling is its ability to reflect our own lives back at us. It mirrors the choices we face, the roads we didn't take, and the endless what-ifs that linger in our minds. It's a reminder that life is full of possibilities, and that every decision we make shapes the story of who we are. At the same time, it challenges us to think beyond the confines of our own reality, to imagine worlds where the rules are different, and where the boundaries of what's possible are endlessly redefined. This cultural fascination with the multiverse also speaks to something deeper, our innate desire to explore, to question, and to dream. It's a testament to the power of the human imagination and its ability to transform abstract ideas into stories that move us, challenge us, and inspire us. Whether through a superhero's journey or a painter's brushstroke, the multiverse invites us to see the world and ourselves in a new light. As we immerse ourselves in these stories and works of art, we're reminded that the multiverse isn't just a scientific theory or a narrative device. It's a reflection of our collective curiosity, our yearning to understand the infinite, and our enduring belief that there's always more to discover. And in that sense, the multiverse isn't just shaping our culture. It's shaping us, inviting us to imagine, to question, and to dream of the infinite possibilities that lie beyond the horizon of our understanding. For centuries, humanity has turned to spirituality and religion to make sense of the cosmos, to find meaning in the vastness of existence. But what happens when science enters the conversation, offering ideas like the multiverse that stretch the boundaries of our understanding? For many, the multiverse isn't just a scientific concept. It's a profound idea that resonates with spiritual and philosophical questions about life, the divine, and our place in the grand scheme of things. Could the multiverse offer a new way to think about the sacred, or does it shake the foundations of traditional beliefs? Let's explore this fascinating intersection of science and spirituality. At its core, the multiverse challenges the idea of a single, unchanging reality. It suggests that existence is far more complex and layered than we once imagined, a tapestry of infinite possibilities, each one a unique expression of the cosmos. For some spiritual traditions, this idea isn't entirely unfamiliar. Hinduism, for example, speaks of countless worlds and realms, each governed by its own set of laws and inhabited by beings with different purposes. The multiverse, in this sense, echoes ancient wisdom, offering a scientific framework for ideas that have been part of spiritual thought for millennia. But for other belief systems, the multiverse might seem at odds with traditional teachings. If every possible universe exists, does that mean there's no singular, divine plan? Or could the multiverse itself be seen as an expression of an even greater creative force, a way for the divine to explore every possible outcome? Some theologians argue that the multiverse doesn't diminish the idea of a higher power, it expands it. Instead of a single, linear creation story, the multiverse suggests a cosmos of infinite creativity, where every possibility is realized in its own unique way. This interplay between science and spirituality also raises questions about purpose and meaning. If the multiverse is real, does that make life less significant or more so? For some, the idea of infinite realities might feel overwhelming, as though our choices are just one thread in an endless tapestry, but others see it as an affirmation of life's richness, a reminder that every moment, every decision, contributes to the vast diversity of existence. In this view, the multiverse doesn't erase meaning, it multiplies it, inviting us to see our lives as part of something much larger. Of course, not everyone sees the multiverse through a spiritual lens. For some, it's purely a scientific idea, one that challenges us to think beyond the limits of our own reality. But even in this perspective, there's room for wonder. The multiverse reminds us that the universe, or universes, are full of mysteries we've yet to uncover. It invites us to ask questions that go beyond the physical, touching on the very essence of what it means to exist. What's remarkable about this dialogue between science and spirituality is how it brings together different ways of understanding the world. It's not about choosing one over the other, but about finding connections, about seeing how ancient wisdom and modern science can inform and enrich each other. Whether you view the multiverse through the lens of faith, philosophy, or physics, it's a concept that invites us to think deeply about the nature of reality and our place within it. As we explore these ideas, we're reminded that the search for knowledge isn't just about uncovering facts, it's about understanding ourselves and the world in new ways. The multiverse doesn't just challenge traditional beliefs, it opens up new possibilities for how we think about the divine, the cosmos, and the infinite tapestry of existence. And in this journey, we're all explorers, seeking to bridge the gap between the known and the unknown, the scientific and the spiritual, in our quest to make sense of the infinite. What if the key to humanity's next great economic leap isn't on Earth or even in our universe? Exploring the multiverse isn't just a scientific endeavor, it's a potential goldmine of economic opportunity. From groundbreaking technologies to new industries, the financial implications of understanding the multiverse could be as vast as the concept itself. But with great potential comes great responsibility. How should society invest in this frontier, and what are the risks of diving headfirst into the unknown? Let's break it down. First, consider the economic benefits of multiverse research. Funding scientific exploration has always been a catalyst for innovation. The Apollo program, for instance, didn't just land humans on the moon. It spurred advancements in computing, materials science, and even everyday products like memory foam and cordless tools. Similarly, investing in multiverse research could lead to breakthroughs in quantum computing, energy, and telecommunications. Imagine a future where we harness the principles of other universes to develop technologies that revolutionize industries, from healthcare to transportation. The ripple effects could be transformative, creating jobs, driving economic growth, and solving some of humanity's most pressing challenges. But innovation isn't the only potential payoff. The multiverse could also inspire entirely new industries. Take space exploration as an analogy. The race to the stars has given rise to a booming space economy, from satellite technology to asteroid mining. If we discover that other universes are not only real but accessible even indirectly, we could see the birth of entirely new sectors. Perhaps businesses would emerge to develop tools for detecting multiverse phenomena, or to explore the philosophical and ethical implications of interacting with alternate realities. The possibilities are as limitless as the multiverse itself. Of course, with opportunity comes risk. One major concern is the allocation of resources. Multiverse research is expensive, requiring cutting-edge technology and highly specialized talent. Governments and private investors would need to weigh the potential benefits against other pressing needs, like climate change, poverty, and healthcare. There's also the risk of overpromising. If funding pours into multiverse research without clear milestones or tangible returns, it could lead to public disillusionment and a loss of trust in scientific endeavors. Balancing ambition with pragmatism will be crucial. Another challenge is the potential for inequality. If multiverse research leads to groundbreaking technologies, who gets to benefit? Will these advancements be accessible to all, or will they widen the gap between the haves and have-nots? History shows that technological progress often exacerbates inequality, at least in the short term. To avoid this, we'll need frameworks that ensure the benefits of multiverse exploration are shared equitably, whether through policy, education, or international collaboration. Then there's the question of ethics. While the economic potential of the multiverse is exciting, we can't ignore the moral implications. What happens if we discover a universe with sentient life? How do we navigate the ethical dilemmas of interacting with or exploiting another reality? These aren't just philosophical questions, they're practical ones that could have real economic and social consequences. Addressing them proactively will be essential to ensuring that multiverse exploration benefits humanity as a whole. So, how should society approach this frontier? A balanced strategy is key. Governments, private investors, and research institutions will need to work together, pooling resources and expertise to tackle the multiverse's biggest questions. Public engagement will also be critical. By fostering a sense of shared ownership and curiosity, we can ensure that the economic benefits of multiverse exploration are matched by a deeper understanding of its implications. The multiverse isn't just a scientific concept, it's a financial and ethical challenge, one that invites us to think big about what's possible. As we consider how to invest in this frontier, we're not just shaping the future of science, we're shaping the future of humanity. And in that journey, the stakes are as high as the rewards are vast. The multiverse isn't just a question of what's out there, it's a question of what we're willing to invest in discovering it. The multiverse isn't just a topic for scientists and philosophers, it's a gateway to sparking curiosity and imagination in learners of all ages. Imagine a classroom where students aren't just memorizing facts, but actively exploring the boundaries of what's possible. Teaching about the multiverse offers a unique opportunity to blend science, philosophy, and creativity, creating a learning experience that's as expansive as the concept itself. But how can educators bring something as abstract as the multiverse into the classroom, and what lessons can students and all of us take away from it? One approach is to start with the familiar and build toward the extraordinary. For younger students, this might mean using relatable analogies, like comparing the multiverse to a library filled with endless books, each one a different story about how reality could unfold. For older students, it could involve diving into the science behind the multiverse, from quantum mechanics to string theory, and discussing how these ideas challenge our understanding of the universe. By grounding abstract concepts in relatable examples, educators can make the multiverse accessible while still leaving room for wonder. But the multiverse isn't just a science lesson, it's a springboard for critical thinking and debate. Imagine a classroom discussion where students explore the philosophical implications of infinite realities. What does it mean to have countless versions of yourself? How do we define identity in a multiverse? These questions don't have easy answers, but they encourage students to think deeply, question assumptions, and engage with ideas that stretch the limits of their imagination. It's not just about learning facts, it's about developing the skills to grapple with complex, open-ended questions. Another powerful way to teach about the multiverse is through storytelling. Whether it's through literature, film, or creative writing, stories allow students to explore the what-ifs of alternate realities in a way that's both personal and profound. A student writing a story about a parallel universe where history took a different turn isn't just practicing their craft. They're engaging with concepts like cause and effect, decision-making, and the nature of reality. Stories bring the multiverse to life, making it a tool for both learning and self-expression. Of course, teaching about the multiverse also comes with challenges. How do educators balance the excitement of speculative ideas with the rigor of scientific evidence? One way is to emphasize the process of science, the way theories are developed, tested, and refined over time. By framing the multiverse as a hypothesis rather than a proven fact, educators can inspire curiosity while also teaching students to think critically about what we know and what we're still trying to figure out. The lessons of the multiverse extend beyond the classroom too. It reminds us that the universe, or universes, are full of mysteries waiting to be explored. It encourages us to ask big questions, challenge assumptions, and embrace the unknown. And perhaps most importantly, it teaches us that learning isn't just about finding answers. It's about cultivating a sense of wonder and a willingness to explore the infinite possibilities of existence. As educators and learners alike, the multiverse offers a unique opportunity to expand our horizons. both intellectually and imaginatively. It's a reminder that the pursuit of knowledge isn't just about understanding the world as it is, it's about imagining the world as it could be. And in that sense, the multiverse isn't just a concept to teach. It's an invitation to dream, to question, and to discover the endless potential of the human mind. What if the existence of infinite universes doesn't just expand our understanding of reality? It also deepens our responsibility to care for the one we inhabit. The multiverse theory, while mind-bending in its scope, might just hold a mirror up to our own world, challenging us to rethink how we approach environmentalism and sustainability. If there are countless other universes out there, each with its own set of physical laws and conditions, it raises a profound question. What makes our universe and our planet so uniquely precious? At first glance, the multiverse might seem to diminish the importance of our own reality. After all, if there are infinite universes, isn't ours just one among many? But here's the twist: the multiverse could actually amplify the value of our world. In a cosmos of infinite possibilities, Earth stands out as a rare gem, a planet teeming with life, biodiversity, and beauty. It's a reminder that even in a sea of possibilities, the conditions that allow life to flourish are extraordinarily rare and worth protecting. This perspective aligns closely with the principles of environmentalism. Just as the multiverse highlights the uniqueness of our universe, environmentalism emphasizes the irreplaceable value of our planet's ecosystems. From the Amazon rainforest to coral reefs, these natural wonders aren't just resources, they're part of a delicate balance that sustains life. The multiverse theory invites us to see Earth not as an isolated speck in the void, but as a rare and interconnected web of life in an otherwise vast and potentially lifeless expanse. But the connection between the multiverse and environmentalism goes even deeper. If we accept that other universes might exist with their own versions of Earth, it raises questions about how those worlds are faring. Are there universes where humanity made different choices, avoiding the environmental crises we face today? Or are there realities where life never emerged at all, leaving barren landscapes untouched by conscious beings? These hypothetical scenarios aren't just thought experiments, they're a call to reflect on the choices we're making here and now. One of the most compelling aspects of the multiverse theory is its emphasis on diversity. Just as the multiverse celebrates the infinite variety of possible realities, environmentalism champions the diversity of life on Earth. Every species, from the tiniest microbe to the largest whale, plays a role in the intricate tapestry of our planet's ecosystems. The multiverse reminds us that diversity isn't just a feature of the cosmos, it's a fundamental principle that sustains existence itself. This connection also challenges us to think about sustainability in a broader context. If we're part of a multiverse, our actions don't just affect our own reality, they ripple across the infinite possibilities of existence. Every decision we make, from reducing carbon emissions to preserving natural habitats, becomes part of a larger story, one that extends beyond the boundaries of our universe. It's a perspective that transforms environmentalism from a local or even global concern into a cosmic responsibility. Of course, this doesn't mean we should lose sight of the immediate challenges we face. Climate change, deforestation, and pollution are urgent issues that demand action now, not in some distant multiverse. But the multiverse theory offers a powerful lens through which to view these challenges. It reminds us that our planet is a rare and precious oasis in an infinite sea of possibilities, and that protecting it isn't just a matter of survival, It's a testament to the extraordinary potential of existence itself. As we reflect on the intersection of the multiverse and environmentalism, one thing becomes clear. The choices we make today will shape not just our own future, but the legacy we leave in the grand tapestry of the cosmos. Whether or not other universes exist, our responsibility to care for this one remains unchanged. And in that sense, the multiverse isn't just a scientific idea, it's a call to action, inviting us to cherish and protect the extraordinary world we call home. Contemplating the multiverse isn't just an intellectual exercise, it's an emotional journey, the idea that there could be infinite versions of reality, each with its own version of you, can be both exhilarating and deeply disorienting. On one hand, it sparks a sense of wonder, opening our minds to the boundless possibilities of existence. On the other, it can leave us questioning our place in the cosmos, our identity, and even the significance of our choices. How does this duality shape our mental health, and what does it reveal about the human experience? For many, the multiverse is a source of profound awe. It invites us to imagine a cosmos brimming with endless stories, where every decision creates a new reality. This perspective can be liberating, offering a sense of freedom from regret or fear of failure. After all, if every possible outcome exists somewhere, does it really matter if you took the wrong path? This mindset can reduce anxiety, helping us embrace life's uncertainties with curiosity rather than dread. It's a reminder that no matter what happens, we're part of something vast and interconnected, a tapestry of infinite possibilities, but alongside this awe comes a quieter, more unsettling side. The multiverse can challenge our sense of individuality. If there are countless versions of you out there, some living lives you've only dreamed of, others facing hardships you've avoided, what makes you unique? It's a question that can stir feelings of insignificance, as though our lives are just one drop in an infinite ocean. For some, this realization can lead to existential unease, a sense that our choices and struggles might not hold the weight we once thought they did. This tension between awe and unease isn't new. Philosophers and thinkers have long grappled with the tension between the infinite and the finite, the cosmic and the personal. What's unique about the multiverse is how it brings these abstract ideas into sharp, personal focus. It's one thing to ponder the vastness of the cosmos. It's another to imagine a version of yourself living a completely different life. This duality can be both a source of inspiration and a psychological challenge, depending on how we choose to engage with it. So, how can we navigate these psychological effects? One approach is to embrace the multiverse as a tool for self-reflection. Instead of seeing infinite realities as a threat to our individuality, we can view them as a mirror, reflecting the infinite potential within ourselves. Every decision, every moment, becomes an opportunity to explore who we are and who we might become. This perspective shifts the focus from what we've missed to what we can create, turning the multiverse into a source of empowerment rather than existential dread. Another key is balance. It's natural to feel overwhelmed by the enormity of the multiverse, but we don't have to dwell there. By grounding ourselves in the present, in the tangible, everyday experiences that give our lives meaning, we can find stability amidst the infinite. Whether it's through mindfulness, creative expression, or simply connecting with loved ones, these practices remind us that while the multiverse might be vast, our lives are deeply personal and uniquely our own. Ultimately, the psychological impact of the multiverse depends on how we choose to engage with it. It can be a source of wonder, a catalyst for growth, or a reminder of our place in a much larger story. And in that sense, the multiverse isn't just a scientific idea, It's a reflection of the human experience, inviting us to explore not just the cosmos, but the depths of our own minds and hearts. As we navigate this journey, we're reminded that the universe, or universes, are as much about us as they are about the stars. The multiverse isn't just a playground for scientists and philosophers, it's a boundless source of inspiration for artists. Imagine a canvas where every brushstroke creates a new reality, or a symphony where each note echoes across infinite dimensions, from the surreal landscapes of Salvador Dali to the mind-bending narratives of Philip K. Dick. Artists have long been drawn to the idea of alternate realities, using their work to explore the mysteries and possibilities of the multiverse. Their creations don't just reflect the concept, they bring it to life, inviting us to see the cosmos through a lens of wonder and imagination. Consider visual art, where the multiverse becomes a kaleidoscope of colors, shapes, and textures. Artists like Yayoi Kusama have used patterns and repetition to evoke the infinite, creating immersive installations that make viewers feel as though they've stepped into another dimension. Kusama's famous Infinity Mirrors series, with its endless reflections of light and space, captures the essence of the multiverse, a place where boundaries dissolve and the infinite unfolds before our eyes. These works don't just depict the multiverse, they allow us to experience it, even if only for a moment. Music, too, has embraced the multiverse as a theme. Composers and musicians often explore the idea of alternate realities through sound, crafting pieces that feel otherworldly and expansive. Think of the haunting melodies of Björk's Biophilia, which weaves together themes of nature, technology, and the cosmos. Or consider the experimental sounds of artists like Aphex Twin, whose layered compositions create a sense of infinite depth, as though each track is a portal to a different reality. Music, in this sense, becomes a way to navigate the multiverse, offering a sonic journey through the infinite possibilities of existence. Literature and storytelling have perhaps the most direct connection to the multiverse, using narrative to explore the what-ifs of alternate realities. Neil Gaiman's The Sandman series, for example, takes readers on a journey through countless worlds, each one shaped by dreams, myths, and the choices of its characters. These stories don't just entertain, they challenge us to think about how our own choices might ripple across realities, shaping the world around us in ways we can't always predict. What's fascinating about these artistic interpretations is how they shift our perspective. While scientists seek to understand the multiverse through equations and experiments, artists approach it through emotion and imagination. They remind us that the multiverse isn't just a collection of facts or theories, it's a canvas for exploring the human experience. Through their work, we're invited to ask questions about identity, purpose, and the nature of reality itself. Art also has a unique ability to make the multiverse accessible. While the science behind it can feel abstract or intimidating, a painting, a song, or a story can bring the concept to life in a way that's immediate and visceral. It's one thing to read about parallel universes in a physics textbook. It's another to step into an art installation that makes you feel as though you're standing at the edge of infinity. As we celebrate the creativity of the multiverse, we're reminded that art and science are two sides of the same coin. Both seek to explore the unknown, to push the boundaries of what we think is possible. And in the case of the multiverse, they come together to create something truly extraordinary, a vision of reality that's as boundless as the human imagination. Through the eyes of artists, the multiverse becomes more than just a scientific idea. It becomes a source of beauty, mystery, and endless inspiration. And as we explore their work, we're invited to see the cosmos not just as a place of cold, hard facts, but as a living, breathing tapestry of possibilities, one that's waiting for us to add our own unique thread. The multiverse isn't just a topic of fascination for science fiction fans, it's a hotly debated subject among scientists themselves. While some researchers see it as a groundbreaking framework for understanding the cosmos, others argue it's little more than speculation, untestable, and beyond the reach of empirical science. This divide has sparked one of the most intriguing debates in modern physics, raising questions about what science can and should explore. So, how do scientists approach the multiverse, and what are the key arguments shaping this conversation? On one side of the debate are those who see the multiverse as a natural extension of existing theories. For them, it's not just a wild idea, but a logical consequence of cutting-edge science. Take cosmic inflation, for example. If the early universe expanded exponentially, creating bubbles of space-time, isn't it plausible that other bubbles, other universes, exist beyond our own? Similarly, the many worlds interpretation of quantum mechanics suggests that every quantum decision spawns a new universe. For proponents, these theories aren't just mathematical curiosities, they're hints of a deeper, multiverse reality. But not everyone is convinced. Critics argue that the multiverse is fundamentally untestable. If other universes exist beyond our observable reach, how can we ever prove they're real? Science, they say, relies on evidence, on observations and experiments that can be repeated and verified. Without the ability to directly observe or interact with other universes, the multiverse risks becoming a matter of faith rather than fact. Some even worry that embracing the multiverse could undermine the credibility of science, turning it into a speculative endeavor rather than a rigorous pursuit of knowledge. This tension between theory and testability lies at the heart of the debate. Supporters counter that indirect evidence, like anomalies in the cosmic microwave background or unexplained phenomena in particle physics, could point to the existence of other universes. They argue that dismissing the multiverse outright could close the door on potentially revolutionary discoveries. After all, many scientific ideas, from black holes to the Big Bang, were once considered untestable before technology and ingenuity caught up. Another layer of the debate centers on philosophy. For some scientists, the multiverse aligns with the principle of Occam's razor, which favors simpler explanations over complex ones. If the multiverse can explain the fine-tuning of our universe's physical constants, why gravity, for example, is just strong enough to allow stars and galaxies to form, it might be the simplest solution. But critics argue that invoking an infinite number of universes to explain one is anything but simple. It's a philosophical tug of war, with each side questioning what it means to truly explain the cosmos. The multiverse debate also highlights the evolving nature of science itself. As our understanding of the universe grows, so do the questions we ask, and the tools we need to answer them. Some scientists believe that future advancements in technology, like more powerful telescopes or quantum computers, could bring the multiverse within the realm of testability. Others remain skeptical, insisting that science must stay grounded in what we can observe and measure. What's clear is that the multiverse isn't just a scientific idea, it's a conversation about the limits of human knowledge. It challenges us to think beyond the boundaries of our own reality, to imagine possibilities that might lie forever beyond our reach. And whether you're a believer, a skeptic, or somewhere in between, the multiverse debate reminds us that science is as much about asking questions as it is about finding answers. It's a journey of curiosity, creativity, and above all, the courage to explore the unknown. Mathematics has always been the silent architect of the cosmos, a universal language that underpins everything from the orbits of planets to the behavior of subatomic particles. When it comes to the multiverse, math becomes even more essential. It's the tool we use to model the infinite, to explore realities beyond our own, and to ask questions that push the boundaries of what we thought was possible. But how exactly does mathematics help us navigate the mind-bending concept of infinite universes? Let's dive into the numbers behind the theory. At its core, mathematics provides the framework for understanding the multiverse. Take probability, for example. In a multiverse where every possible outcome exists, probability becomes a way to map the likelihood of different realities. Imagine rolling a six-sided die. In our universe, it lands on a 3, but in a multiverse, every possible roll happens in its own separate universe. A 1, a 2, all the way up to 6. Mathematics allows us to quantify these possibilities, giving us a way to think about the infinite without getting lost in its enormity. But math doesn't stop at probability. Geometry also plays a key role, especially in theories like string theory, which suggests the existence of extra dimensions beyond the 3 we experience. These hidden dimensions aren't just abstract ideas, they're mathematical constructs, folded and curled in ways that shape the very fabric of reality. Picture a piece of paper. To a two-dimensional being, it's flat and finite. But to us, it's part of a three-dimensional world. In the same way, higher dimensional geometries might hold the key to understanding how multiple universes could coexist, each one a unique expression of space and time. Equations are another critical tool. The laws of physics, from gravity to quantum mechanics, are written in the language of math. These equations don't just describe our universe, they hint at the possibility of others. For instance, the equations governing inflation theory suggest that the rapid expansion of the early universe could have created bubbles of space-time, each one a separate universe with its own physical laws. Without math, we wouldn't even have the vocabulary to describe these ideas, let alone explore them. What's remarkable is how mathematics bridges the gap between the abstract and the tangible. It takes concepts that seem too vast or strange to grasp, like infinite universes or higher dimensions, and gives them structure, making them accessible to our minds. This is why math is more than just a tool for scientists. It's a lens through which we can see the multiverse in all its complexity and wonder. But here's the twist. Mathematics doesn't just help us understand the multiverse, it challenges us to think differently about reality itself. In a multiverse, the rules of math might not be the same everywhere. Some universes could have entirely different geometries, or even alternate forms of logic. This raises fascinating questions about the nature of mathematics. Is it a human invention, a tool we've created to make sense of the world, or is it something more fundamental, a universal truth woven into the fabric of existence? As we explore these questions, we're reminded that mathematics isn't just about numbers or equations. It's about curiosity, creativity, and the relentless pursuit of knowledge. It's the language that allows us to converse with the cosmos, to ask questions that have no easy answers, and to imagine realities beyond our wildest dreams. And in the case of the multiverse, it's the key that unlocks the door to the infinite, inviting us to explore a universe, or universes, that are as boundless as the numbers themselves. The future of multiverse research is brimming with possibilities, fueled by cutting-edge technology and the relentless curiosity of scientists. Imagine a world where we don't just theorize about other universes. We detect them, study them, and perhaps even interact with them in ways we can't yet imagine. This isn't just science fiction. It's the direction multiverse research is heading, and the tools being developed today could revolutionize our understanding of reality tomorrow. One of the most exciting advancements on the horizon is the next generation of telescopes. Instruments like the James Webb Space Telescope have already transformed our view of the cosmos, but future telescopes could take us even further. Projects like the Vera C, Rubin Observatory, and the European Extremely Large Telescope are designed to peer deeper into space and time, searching for clues that might hint at the existence of other universes. These observatories could detect anomalies in the cosmic microwave background, subtle imprints left by collisions between our universe and others, or uncover new phenomena that challenge our current understanding of physics. But it's not just about looking up at the stars. Advances in quantum computing are opening up entirely new ways to explore the multiverse. Quantum computers, with their ability to process vast amounts of data simultaneously, could simulate complex quantum systems that mimic the behavior of other universes. These simulations wouldn't just test theories, they could reveal patterns and connections that point to the existence of parallel realities. It's like having a virtual multiverse lab, where scientists can experiment with ideas that were once purely theoretical. Another frontier is the study of gravitational waves. Since their first detection in 2015, these ripples in space-time have become a powerful tool for exploring the cosmos. Future detectors, like the Laser Interferometer Space Antenna LISA, will be sensitive enough to pick up even fainter signals, potentially revealing evidence of multiverse interactions. If two universes collided in the distant past, the gravitational waves from that event could still be echoing through the cosmos, waiting to be discovered. Of course, the road ahead isn't without challenges. Multiverse research requires not just technological innovation, but also a willingness to embrace the unknown. Scientists will need to develop new frameworks for interpreting data, as well as new ways to test theories that might never be directly observable. This is where collaboration becomes key, bringing together physicists, mathematicians, and technologists to tackle questions that no single field can answer alone. What's truly exciting is how these breakthroughs could reshape our understanding of reality. If we find evidence of other universes, it wouldn't just confirm a scientific theory, it would transform how we see ourselves and our place in the cosmos. Are we alone, or part of an infinite tapestry of realities? What does it mean to exist in a multiverse where every possibility plays out somewhere? These are questions that could redefine not just science, but philosophy, art, and even our everyday lives. As we look to the future, one thing is clear: the search for the multiverse is a journey of discovery, driven by the same curiosity that has propelled humanity forward for centuries. Whether through telescopes, quantum computers, or gravitational wave detectors, we're on the brink of uncovering secrets that could change everything we thought we knew about existence. And in that pursuit, we're not just exploring the cosmos, we're exploring the infinite possibilities of what it means to be human. The multiverse doesn't just challenge our understanding of physics, it invites us to explore the very nature of reality itself. At the intersection of science and philosophy, the questions become as profound as they are complex. What does it mean for something to exist? How do we define knowledge when the boundaries of reality might stretch far beyond what we can observe? These aren't just scientific inquiries, they're philosophical puzzles that have puzzled thinkers for centuries. And now, the multiverse is bringing these two worlds together in ways that are as fascinating as they are transformative. Science, at its core, seeks to explain the how of the universe, the mechanisms, the laws, the observable phenomena. It's a discipline built on evidence, experimentation, and the relentless pursuit of understanding. Philosophy, on the other hand, delves into the why. It asks questions about meaning, purpose, and the nature of existence itself. While these fields might seem distinct, they've always been intertwined. Thinkers like Aristotle and Newton didn't just study the natural world, they pondered its deeper implications. And today, the multiverse is reigniting that dialogue, pushing both science and philosophy to new frontiers. Consider the nature of reality. In science, reality is often defined by what we can measure and observe, but the multiverse suggests that reality might be far more expansive, with realms that lie forever beyond our reach. This raises a philosophical question. If we can't observe or interact with something, does it still exist? For scientists, the challenge is to find ways to test these ideas, even indirectly. For philosophers, it's an opportunity to rethink what we mean by existence itself. It's a conversation that doesn't just bridge the gap between these fields, it expands the boundaries of both. Then there's the question of knowledge. In a multiverse, our understanding of the cosmos becomes both broader and more uncertain. If every possible universe exists, how can we ever know which one we're in? And what does that mean for the pursuit of truth? Philosophers have long debated the limits of human knowledge, from Plato's allegory of the cave to modern theories of epistemology. The multiverse adds a new layer to this debate, challenging us to consider whether knowledge is absolute or relative, whether it's shaped by the universe we inhabit or transcends it altogether. But the intersection of science and philosophy isn't just about questions, it's about collaboration. Scientists bring tools and methods to test ideas, while philosophers provide frameworks to interpret and critique them. Together, they help us navigate the complexities of the multiverse, balancing the rigor of evidence with the depth of reflection. It's a partnership that reminds us that understanding the cosmos isn't just about collecting data, it's about grappling with the profound questions that data raises. What's remarkable about this dialogue is how it enriches both fields. Science gains a deeper sense of context, grounding its discoveries in the broader questions of existence. Philosophy, in turn, gains new ways to explore age-old questions, informed by the latest advancements in physics and cosmology. And for us, as observers and learners, it's an invitation to think bigger, to see the multiverse not just as a scientific idea, but as a lens through which we can explore the mysteries of existence itself. As we continue to explore the multiverse, we're reminded that the search for knowledge is as much about asking the right questions as it is about finding answers. It's a journey that bridges the empirical and the abstract, the measurable and the meaningful, and in that journey, science and philosophy aren't just partners, they're guides, helping us navigate the infinite possibilities of reality and our place within it. What does it take to explore the multiverse? While science gives us the tools to test theories and analyze data, there's another essential ingredient: imagination. It's the spark that turns abstract equations into vivid possibilities, the force that allows us to envision realities beyond our own. Without imagination, the multiverse would remain a collection of mathematical models, fascinating but distant. With it, we can step into the unknown and ask questions that push the boundaries of what's possible. Think about how imagination has shaped our understanding of the cosmos. Long before telescopes or particle accelerators, humans looked up at the night sky and wondered what lay beyond. They told stories, created myths, and imagined worlds filled with gods, monsters, and alternate realities. These early imaginings weren't just flights of fancy, they were the first steps toward understanding the universe. Today, we use imagination in much the same way, turning complex theories into vivid scenarios that help us make sense of the multiverse. Take the many worlds interpretation as an example. It's one thing to read about quantum mechanics and the idea that every decision creates a new universe. It's another to picture yourself standing at a crossroads, each path leading to a different version of your life. Imagination transforms the abstract into the personal, allowing us to connect with ideas on a deeper level. It's not just about understanding the science, it's about experiencing it, even if only in our minds. But imagination isn't just a tool for understanding, it's also a catalyst for discovery. Some of the greatest breakthroughs in science have come from moments of creative thinking. Albert Einstein famously imagined riding on a beam of light, an exercise that led to his theory of relativity. Similarly, the multiverse invites us to think beyond the limits of our experience, to ask, what if, and follow those questions wherever they lead. What if gravity works differently in another universe? What if time flows backward? By letting our imaginations roam, we open the door to ideas that might otherwise remain hidden. Of course, imagination alone isn't enough. It needs to be paired with scientific rigor, with experiments and evidence that ground our ideas in reality. But without imagination, science risks becoming stagnant, confined to what we already know. The multiverse reminds us that the cosmos is vast and mysterious, full of questions we haven't even thought to ask yet. To explore it fully, we need both the precision of science and the daring of creativity. So, how can we harness imagination in our own lives? Start by asking questions. What would it feel like to live in a universe with two suns? How would life evolve in a reality where the laws of physics are completely different? These questions might not have easy answers, but they stretch our minds, helping us see the world and the multiverse in new ways. Ultimately, the role of imagination in exploring the multiverse is about more than just dreaming up possibilities. It's about cultivating a sense of wonder, a willingness to embrace the unknown and see where it takes us. Whether you're a scientist, a storyteller, or simply someone who's curious about the cosmos, imagination is your guide, your compass in the infinite sea of realities. And in that journey, the only limit is how far you're willing to let your mind wander. The multiverse isn't just a Western concept, it's a global one, sparking curiosity and debate across cultures and continents. From ancient philosophies to modern science, people around the world have long been fascinated by the idea of multiple realities. But what's remarkable is how these perspectives differ, offering unique insights that enrich our understanding of the multiverse. By exploring how different cultures approach this idea, we can see the multiverse not just as a scientific theory, but as a universal story, one that transcends borders and connects us all. Take ancient Hindu cosmology, for example. Long before modern physics, texts like the Puranas described a universe filled with countless worlds, each governed by its own set of laws and inhabited by beings with different purposes. These worlds weren't just random, they were part of a cosmic order, a vast tapestry of existence. This vision of the multiverse isn't just about science, it's about spirituality, reflecting a deep connection between the cosmos and the divine. In indigenous traditions, the idea of multiple realities often takes a more personal form. Many Native American cultures, for instance, speak of parallel worlds or dimensions that exist alongside our own. These realms aren't just abstract ideas, they're places where ancestors reside, where spirits guide the living, and where the boundaries between the physical and the spiritual blur. For these communities, the multiverse isn't a distant concept. It's woven into the fabric of daily life, shaping rituals, stories, and relationships with the natural world. Then there's the scientific perspective, which has gained momentum in recent decades thanks to contributions from researchers around the globe. In Japan, for example, physicists like Michio Kaku have explored the implications of string theory and extra dimensions, while in Europe, institutions like CERN are testing the limits of quantum mechanics. Meanwhile, in countries like India and Brazil, scientists are using cutting-edge technology to study the cosmic microwave background, searching for clues that might hint at the existence of other universes. This global collaboration shows that the multiverse isn't just a theoretical playground, it's a shared pursuit, one that brings together minds from every corner of the world. But the multiverse isn't just a topic for scientists and spiritual thinkers. It's also a source of inspiration for artists and storytellers. In African folklore, for instance, tales of alternate worlds and parallel existences often serve as metaphors for social and moral lessons. These stories remind us that the multiverse isn't just about physics. It's about exploring the human condition, asking questions about identity, choice, and the consequences of our actions. What's fascinating about these diverse perspectives is how they complement each other. While science gives us the tools to test and explore the multiverse, cultural and spiritual traditions offer frameworks for understanding its deeper meaning. Together, they create a richer, more nuanced picture of what the multiverse could be, not just a collection of universes, but a reflection of our shared curiosity and creativity. This global view also challenges us to think beyond our own assumptions. What if the multiverse isn't just a Western idea, but a universal one? What if the questions we're asking about existence, identity, and purpose are being asked in different ways across the world? By listening to these voices, we gain not just new insights, but a deeper appreciation for the ways in which the multiverse connects us all. As we explore these global perspectives, one thing becomes clear: the multiverse isn't just a scientific theory or a philosophical idea. It's a story, one that's being written by people everywhere in countless languages and traditions. And in that story, we're not just observers, we're participants, adding our own unique thread to the infinite tapestry of existence. Whether through science, spirituality, or art, the multiverse invites us to see the world and ourselves in a new light, reminding us that the search for knowledge is as universal as the cosmos itself. The multiverse isn't just a grand cosmic theory, it's a mirror reflecting the infinite possibilities of our own lives. Think about it. Every decision you've ever made, every path you've taken or left behind, could have led to a completely different reality. In one universe, maybe you pursued that dream job across the country. In another, you stayed close to home, building a life in a different way. The multiverse doesn't just exist out there in the cosmos. It's woven into the fabric of our personal stories, reminding us that life is a tapestry of choices, each one creating its own unique thread. This idea can be both liberating and humbling. On one hand, it invites us to embrace the what-ifs with curiosity rather than regret. If every possible outcome exists somewhere, does it really matter if you took the wrong path? In some universe, that version of you is thriving. On the other hand, it challenges us to reflect on the weight of our decisions. If every choice spawns a new reality, are we truly free to shape our lives, or are we simply actors in an infinite play of possibilities? For many, the multiverse offers a sense of comfort. It's a reminder that no matter what happens, there's always another version of the story, Maybe you didn't get that promotion, or a relationship didn't work out, but in another universe, things unfolded differently. This perspective can help us let go of perfectionism, embracing the beauty of imperfection and the unpredictability of life. At the same time, the multiverse forces us to confront the uniqueness of our own experience. While there may be infinite versions of you out there, this version, the one reading these words right now, is the only one you'll ever know. It's a reminder to cherish the present moment, to make choices that align with your values, and to live authentically in the reality you're in. The multiverse also invites us to think about empathy. If there are countless versions of ourselves, each shaped by different circumstances, doesn't that mean there are countless versions of everyone else, too? This perspective can deepen our understanding of others, reminding us that people are shaped by their own unique paths and choices. It's a call to approach life with compassion, knowing that everyone is navigating their own multiverse of possibilities. Ultimately, the multiverse isn't just a concept to ponder. It's a lens through which we can explore our own lives. It challenges us to ask, what kind of reality do I want to create? What choices will I make today, knowing they ripple across the infinite? And how can I find meaning in a universe, or multiverse, that's so vast and full of possibilities? By making the multiverse personal, we transform it from an abstract idea into a source of inspiration. It's a reminder that life is full of potential, that every moment is a chance to shape the story of who we are. And in that sense, the multiverse isn't just about understanding the cosmos, it's about understanding ourselves and the infinite possibilities we carry within us. The multiverse stands as one of the most captivating and thought-provoking ideas in both science and philosophy. It's a concept that stretches the limits of our imagination, inviting us to consider a cosmos far more vast and intricate than we ever thought possible. From the quantum realm, where particles exist in countless states at once, to the cosmic scale, where entire universes might float like bubbles in an endless sea, the multiverse challenges us to rethink everything we know about reality. This journey through the multiverse has taken us from the tiniest particles to the grandest cosmic structures, from ancient philosophical musings to cutting-edge scientific theories. We've explored how quantum mechanics suggests that every decision might spawn a new universe, how string theory hints at hidden dimensions, and how cosmic inflation could have created a multitude of bubble universes. Each theory offers a unique lens through which to view the multiverse, and together they paint a picture of existence that's as awe-inspiring as it is mysterious. But here's the thing, the multiverse isn't just about science. It's about the questions that have haunted humanity for centuries. What does it mean to exist? Are we alone, or are there infinite versions of ourselves out there, living lives we can only imagine? These questions don't just belong to physicists, they belong to all of us. They remind us that the search for knowledge isn't just about uncovering facts. It's about exploring the very essence of what it means to be human. While we may never have definitive proof of the multiverse, the pursuit of understanding is its own reward. It's a testament to our boundless curiosity and creativity, to our unrelenting desire to push beyond the boundaries of the known. The multiverse isn't just a scientific theory, it's a mirror, reflecting our deepest questions about identity, purpose, and our place in the cosmos. And in that reflection, we find not just answers, but an invitation to keep exploring, to keep questioning, and to keep dreaming. Thank you for joining me on this incredible journey through the multiverse. If you've enjoyed this exploration, don't forget to like, subscribe, and share your thoughts in the comments below. Let's keep the conversation going. because the multiverse isn't just a topic for scientists and philosophers. It's a story we're all a part of. Until next time, stay curious and keep reaching for the infinite.